Welcome everyone for our session about text reuse detection, and which is a significant turn to which we found ourselves walking in the last 2 years. And I am very happy to open this session. Unfortunately, we have a slight change in the plan. Hadar Miller was not able to participate today, and I will present instead a kind of an overview about what we've done so far in the field of text reuse, and will explain the directions Hadar is intending to take. We will have 3 presentations and then the response by Marco Büchler. And our first speaker is Uri Schor. Uri has both degrees in both computer science and Talmud, and he joined us and was a member of the team of the EFRAIM project, and now with respect to his work in the industry, he is still working with us on his spare time on some of our research projects, and I'm very grateful for that. Uri is the developer of Rufus, of which you will hear very soon, and he will present now Rufus, text reuse detection for mapping rabbinic manuscripts. Please.
I'll just share my screen first. Tell me if you can all see the first slide in the presentation. It says Rufus. Great. Thank you, Moshe. I also like working with you, so we're even. Actually, Rufus was already presented by Moshe, Vered, and myself at DH Jewish earlier this year. So I don't want to, I don't know how many people were there. So this will be kind of a recap, not too long, so I won't bore the ones who were. I'm talking to you, Sinai, but enough so everyone understands what Rufus is about. And it's a text reuse detection algorithm. Actually can be referred to more as a method, and it's better for this time of day here in Israel, where algorithm is a bit too much to talk about. And it's a statistical classification method which scales well with the search corpus, the target library. So it can work very well with where the target library is very large, and it can overcome significant variance between the input text, the text that you have in hand, that you're looking for parallels, and the target matches within the corpus. We've developed Rufus initially to identify or to classify if there is no clear identification of mal-transcribed Geniza fragments. These are very bad texts, and they're both partial, fragmentary, and because the low quality of the transcription, they had many other errors. Later on, when we worked on book-long texts in the Tikkun Sofrim projects, the artifacts of the HTR of full Tanhuma manuscripts, we adapted Rufus algorithm to segment and align the long text into paragraphs in the search in the target library, in the search corpus. So the best way to explain how Rufus works is by demonstrating it on a short example. And this is an actual line taken from the HTR, the handwritten text recognition. of Parma 3122 manuscript. And you can see, the ones of you who read the Hebrew, that as an HTR text, it also has errors, but on top of that, this manuscript is different in many ways from the print editions, from the documents that we're searching parallels in. So this is an example of a mistake of the HTR. It's actually a biblical quote, Chanoch lanav al pi darko, very partial biblical quote. And we also try to identify these, the quotes. So how does it work? First, we've taken the library and we've used Safari project, which makes available rabbinical texts in a very friendly license, Creative Commons license, already dissected into passages. So it's very easy to use it as an input source for such a use. And the passages are, the hierarchy is the traditional hierarchy. So we're talking Mishnah or Babylonian Talmud page according to the traditional hierarchy. And then what Rufus does is it iterates the text from beginning to end, working on n-grams on window of words, in this case 3 words, and for each such n-gram, it searches the target library, which was indexed in a full text search engine, for matching documents. So the first n-gram, the first 3 words will result in a list of documents from which we take the top 2. And then it goes over and slides the window. As you can see, if you're quick enough, the windows overlap. So it slides 1 word at a time. So there's an overlap. And once it completes, exhausts the full text, then it aggregates the results and sorts them. And hopefully the best scored documents in the target library, in the corpus, will be the ones that actually match the input text. So this is what the beta GUI graphical user interface looks like. It's a really miniature website. Let me just run an example for a second. And since it's running on a free level, free tier, whatever server, it's not that performant, but still, I wouldn't run it on long text. But this is a line from 2 lines from another Tanhuma manuscript, Geneva 146, and as you can see, the result gave me Tanhuma Re'eh in the first one version of the recension of the Tanhuma as the first score. The other one, Tanhuma Buber, got much lower score. The score here is the ratio between the n-grams that were found as a hit in the matching document and the overall number of n-grams of group of words in the text. And when going over the results, I can see which n-grams actually match the passage below. So it's really better because there's not much to it more than the 3 parameters, which are: the first one is the edit distance, the n-gram size, the number of words, the size of the word window that is rolled over the text. We found 3 grams to be the best performing n-gram size, but I'm sure that it will change, will vary according to the characteristics of the text. And then there's the edit distance, the fuzziness, and this is the number of characters that can change either be added, deleted, or modified within the search query, within the n-grams, between the input text and the matching document in the search in the target corpus. And the last parameter is the word span. And that's the number, the maximum number of words that can be added between two adjacent words in the search query in the n-gram or in the target, the matching document in the target corpus. And that should overcome larger changes such as abbreviations that are expanded, or different phrasing, or in the case of fragmentary text, deletions or omissions of words that are simply not there in the manuscript, and so on. So these are the three parameters that are available in the GUI, which is of course intended for manual interactive usage. It doesn't handle long text. So the three modes in which we use Rufus for now are the GUI that I presented for small units. We are running it offline on larger book-long texts, and we use visualizations that you'll see in Verid's presentation soon. When the data, when this is the best way to look into the data and see when a work is used, when the text switches from one work to another. This is an example of the output in Excel. What we have is we print out for now the first and second best results per line. We go over the text line by line and find the best best result on a window of 15 words. So there is some memory in the algorithm, and you can see that we also look for biblical quotations. So while we run over the text, we're running it against two indexes, two search engine indexes. The first one would be of the Bible verses, and the second one is of rabbinical literature. This slide actually is for the ones who were not attending this presentation, so it recaps what already was covered, hopefully. So the last two slides are what we've come to learn are the strength and the weaknesses, the shortcomings of Rufus, and I'm sure we'll learn more down the road, hopefully. The first one is more of an engineering, I think, strength. It has a good, what we engineers call price-performance ratio. It's very easy to set up, and yet it shows surprisingly good effect performance. So all you need is a search engine, which is an off-the-shelf open source software. We're using Lucene. You can use Elasticsearch, which is basically Lucene. And the software involved is really small. So the algorithm is really not something that's hard to implement. And the good thing is this method is corpus agnostic, so it's generic and it will work for any corpora without the need for tailoring NLP capabilities. So we've ran it. I mean, this corpus that we used is a mixture of Hebrew and Aramaic, but we didn't really attend to it, and it still worked well because it's unaware of the language, of the syntax of the other features of the language. And you can call it a brute force algorithm. It is a brute force algorithm, but in a good way. The unique features, the n-grams that are more rare than the others, the ones that actually would help the researcher lock into the matching document, the matching passages, actually rise above all the white noise that is generated by the more common features. So we don't have to do, we're not trying to filter out the white noise, but rather let this significant result rise above the surface of the white noise. And the parameters that I've touched before, the fuzziness and the word span, which are features of the Lucene search engine, support both changes in inside the word at character level, which can either come from orthography variations, or in our case HTR or transcription errors, but also from bigger, larger variations that the word span will overcome. These include literary variations, phrasing, stylistic, different attributions, etc. And we found the parameterization to be helpful in adapting to different tasks. And the one that we used already was different word span, 0 actually, for biblical for exact quotations from the Bible, and we've tested different word windows until we found the one that seemed to work for us, and it will probably differ for other cases. And it's not all good. We know that the algorithm, first, it's computationally cost, at least theoretically, because for each text, it will generate searches for the size of the text, so its complexity is linear with the length of the input text. The good news is that the performance of the full text search engine is so great because of the internet and us Googling stuff all the time, that it only takes half an hour on a single core to segment and align the text that Verid will soon talk about, that contains over 10,000 lines. The other point I already touched a bit. It lacks the finesse or the sophistication of tailored algorithms, and in that sense, it won't handle translation. So if the input text contains a Hebrew translation of an Aramaic text, it will not find it, and the same goes for texts that use heavily synonyms or abbreviations. And all of these can be mitigated, but this will be a heavy task to implement by the implementation of Lucene analyzer, tokenizers, and filters. But again, this will be a much larger task. And another shortcoming that we've encountered in the manuscript that Verid will talk about is that the target corpus is flat, meaning that it's not hierarchical. So that if, for an example, it contains both primary texts such as Babylonian Talmud, and the secondary text such as commentary on the Talmud that quotes, that has sizable quotations from the Talmud, then when searching this, when using this corpus for the search engine index, you'll get funny results jumping from the primary documents into the secondary, the later documents. We've given some thought on how to work around this, but for now, what we did was creating different indexes for different parts of the corpus. Not an ideal solution, but this is what we did so far. So that concludes my presentation, and we'll go to the questions at the end, Moshe, or?
Yes. Thank you, Uri. We will collect questions in the end, and clearly you can now put questions if you have so on the chat, and we will be able to respond after Marco Büchler's response to the 3 lectures that are presented in this session. So our second speaker is Raziel-Kretzmer, who is the Yuval Ne'eman postdoc fellow leading the project of mapping ontological manuscripts through text reuse detection methods. Vered completed her PhD in Ben-Gurion University. She is an expert in liturgy and in the Jewish paleography, and especially in terms of the Geniza fragments and their uniqueness. And she's working with us for many years, first on in the Midrash project, and later on joined us to the Digital Humanities project in Tikkun Sofrim, and now on this project. So thank you very much, Vered, and the stage is yours. Unmute yourself. Vered, okay.
Can you hear me now?
Yes.
And see my screen? Okay.
Yes.
Okay, rolling window fuzzy search, nicknamed Rufus, whose specifications were lovely presented by Uri, was initiated as a cataloging aid tool as part of a pipeline aiming towards full accessibility of Jewish manuscripts. We aim towards a general tool of full text engine, open code, that could be adapted to any research area and text types by adjusting the index library. In this paper, I will present the initial results of the examination of the algorithm on 2 types of medieval Jewish midrashic manuscripts. First, Tanhuma manuscripts, and then an unpublished anthological essay. Then I'll discuss the intermediate conclusions and the improvements we intend to make following these tests. Our first test case were 2 automatically produced texts of Tanhuma. The Tanhuma literature is a genre of late Midrash originated in the land of Israel. It evolved through a long period of creative transmission, thus represented in many variants. Next to the 2 printed editions, Tanhuma Buber and the print editions, other recensions are extant in sole manuscripts. The various types of text reuse found in Tanhuma variants made them a non-trivial trial for Rufus. For our first test in the Rufus, we ran it over 2 HTRed Tanhuma manuscripts, MS Geneva 146 and Parma 3122. Both were automatically transcribed through eScriptorium and used for our earlier project, Tikkun Sofrim. For MS Geneva, not only we had a moderately mal-transcribed text, its character error rate is 8.9%, we had a corrected full text to compare with. We examined how effective is a tool in analyzing 3 levels of text: a whole manuscript, a large portion, such as a chapter or a homily, and on the finest level, a single line. One of our first observations was that Rufus could cope pretty well with the misspelling of the HTRed text. Of course, the corrected text had produced better results with higher statistical significance. Still, we were generally able to identify most text reuse phenomena through the HTRed text of Manuscript Geneva. The high fuzziness could often overcome the challenge of medium error rate. As for cataloging full manuscripts, MS Parma includes several works copied one after the other on the same codex. This visualization demonstrates the identification of these works. Here, for instance, we can see the transition point between the Tanhuma and Psikta. The chart brings forward other issues of large-scale arrangement, such as the insertion of a large portion of Shir HaShirim Rabbah in the middle of Psikta Rabbati. We can also notice the peak of Tanhuma materials in the middle of the Psikta. Here, these results do not point to an insertion of Tanhumaic section into the Psikta, rather to the similarity between these certain portions in both works. Actually, this anomaly serves as a hint to a more complex type of text reuse, since these portions are both a secondary witness of a homily originated in the earlier work of Psikta de Rav Kahana. Furthermore, the algorithm was an effective tool in determining the affinity of the Tanhuma recension represented in the manuscripts. Here we compared MS Parma to the print edition on the one hand and the Buber edition on the other. As expected, Parma manuscript shows much weaker correlation towards the print edition in the Book of Genesis, and to some extent in Exodus 2, compared to its strong correlation with Tanhuma Buber. Rufus has proven itself with smaller units as well. This is the first page of Manuscript Geneva with its poor 80. It is quite common for a first page of a manuscript to appear worn out and obscure, hence providing with a mal-transcribed HTR. Nonetheless, the GUI was able to identify it for what it is as a Tanhuma Vaikra. But in the first paragraph, not a single engram is marked out as Tanhuma. This is indeed an insertion of a passage from Midrash Agadah, a medieval work, seen on the third result here. This result becomes more significant when the 80 was replaced by the corrected text of this page. To sum up the first examinations based on the HTRed Tanhuma manuscripts, we concluded that A, Rufus is an effective tool for cataloging mal-transcribed Hebrew manuscripts, including those processed through automatic reading. B, that given a relevant reference library, Rufus can identify the content of full manuscripts as well as noticing units to the paragraph level. And C, that due to its fuzziness factors, Rufus is not effective in distinguishing between small text variants, a task that fits better to other existing tools such as Dicta's synopsis builder. Now, for the next phase, we wanted to challenge Rufus with more complex materials and to test his ability to cope with anthological, heavily altered text. Such a challenge was MS London 1389, an anthology of theology, ethics, and general Jewish wisdom arranged by themes. It is built chiefly of Talmud and Midrash passages combined with medieval commentary. This manuscript was known to Jewish scholars interested in the medieval commentary of Baalei Tosafot, such as MARMOUR and Auerbach, but it was never properly published. Already in 1928, MARMOUR felt that the MS anonymity is unreasonable. There is another manuscript in the British Museum, he wrote, which was composed by a scholar in England. Marmorstein believed the provenance of the MS was England, later disagreed by other scholars, which is not only unpublished, but practically unknown. Is it too much to expect that such a work will be made known? It is time that almost 100 years later, his request will be answered. Manuscript London was produced during the 14th century and written in Ashkenazi semi-cursive script. The first sign of use, however, point to Italy. According to ownership and style notes on the back of the codex, this work was part of the rich library owned by the prominent of San Miniato family located in Florence. They were the first Jewish family to gain permission to move into Florence in order to establish a moneylender business in town. On the second day of Iyar 1490, the note on the last page declares, Mrs. Bionda, the widow of Rabbi Mordechai of San Miniato, sold this codex to his nephew, Rabbi Yitzchak. While still in Mordechai's hands, probably during the 70s of the 15th century, the famous censor Markion has left his marks through the manuscripts, adding his signature next to every deletion done by his rule. Markion's signatures were found in other manuscripts extant from the family of San Miniato library, among them the famous Florence manuscripts of the Talmud. During the last decade of the 16th century and the second decade of the 17th century, the codex was censored again and again by the two most active Hebrew censors in medieval Italy, Domenico Yerushalmi in 1595 and Giovanni Domenico Caretto in 1619, both located in Mantova. During the 19th century, the manuscript reappears among the many acquisitions of the French Jewish scholar, book collector, and allegedly forger Eliakim Carmoli, whose signature was found on the bounding pages. Following Carmoli's death in 1875, the codex was finally sold to the British Museum by the bookseller Fischel Hirsch, who took an active role in expanding the museum Hebrew manuscripts collection. The unknown work copied in Manuscript London fits our purpose, for as an anthology arranged by subject, it naturally cites various early Jewish sources beginning in Tannic lore, through Talmud and Midrash, and up to some medieval sources and commentary. Based chiefly on Agadic materials, which tend to be reused in later Midrashim, we expected to have abundance of parallels, quotations, and other text reuse types. Furthermore, the scribe had usually noted his references on the margins next to the cited source. These references are therefore a touchstone according to which Rufus results can be evaluated, particularly in cases where there are many parallels and it is not clear where the text is drawn from. Yet, as we found out when first result had come through, MS London poses greater challenges. Whereas high level of text reuse is to be expected, we did not foresee the amount of adaptation these texts went through. The sources are often heavily altered and rephrased, hence producing ambiguous, uncertain results. Furthermore, the anthology incorporates commentary notes often blended into the text. The lack of clear markers between midrashic source and commentary adds further complication to the effort to identify original text passages. I'll present now some examples of these results in order to demonstrate these challenges and then suggest some further improvements needed as a consequence of these issues. We began the process by HTRing the manuscript through eScriptorium with satisfactory outcomes. The character error rate of 3.6% reflects the high error rate in marginalia transcription, while the main text HTR includes few errors. The results of the source analysis itself, however, were of mixed quality. At first sight, they confirmed that the dominance of the Babylonian Talmud as the main source from which the manuscript draws its materials. In this chart, the Babylonian Talmud citations are painted blue, and even without going into details, the impression we get from the chart corresponds to the picture arises from the marginalia references. Yet, a closer examination had shown that the identification results were not as statistically significant as we received in the Tanhuma analysis. This sample page contains quotations of 4 sources. The painted text marks the line correctly identified by the algorithm. However, the only source explicitly identified in the text from Bavli Evamot, third one, has not been identified by Rufus, probably due to its shortness. In the first source, some of the lines were false positives, error but caused by the fact that both completely different texts mention the same name, Rabban Yochanan ben Zakkai. This example demonstrates a good, though not great, identification rate. This second example demonstrates a more moderate success. The page has 4 references noting the text origins in green circles, and some commentary is blended in yellow circles. In 2 cases, the commentator's name are explicitly mentioned, the 12th century Spanish lexicography Hapirjon, and the famous 11th century Rashi. A large portion of the page is based on Bavli Brachot 18, which is not cited whole. Some parts are omitted and passages from other sources along with commentary are inserted into the discussion. This main unit was successfully recognized, as demonstrated here in the GUI, despite all modification affecting the score. Here again, you can see it in the line-by-line algorithm marked by the painted lines. However, it identified the lexicographic commentary of the Pirchon in lines 6 to 7 as part of the Bavli, missed the first lines of the citation from Ta'anit in lines 10 to 12, and the short citation from Bavli Sanhedrin on line 8 was missed altogether. It thus seems that the brute force of the algorithm works well with extensive passages, but is liable to miss very short ones. The high level of adaptation had caused another type of deviation. In these cases, Rufus is wrong even though it's right, or vice versa. In this example, the anthology cites a midrashic unit from Bavli Brachot 10, and the scribe had mentioned it in the margins. Rufus had indeed identified Bavli Brachot, but the score is only 9%, and it is not the first answer. The algorithm gave a much better score, 17%, to Yalkut Shimoni, which is itself an anthology and therefore clearly a secondary source. Rufus was wrong. This is not the original source from which the author had cited, but it is also right since the version brought in MS London shows higher linguistic resemblance toward the Yalkut version as opposed to the Bavli. This is a significant find. It may say something about transmission patterns and about affinities between the 2 anthologies. Yet, for the purpose of mapping the early sources of the codex, these results create an unwanted noise. In sum, these examples demonstrate that various types of modification, additions, and abbreviation, translation of Aramaic into Hebrew, commentary, and other natural transmitting alternations expose Rufus' limitations and decrease its efficiency in identification of text reuse. At last, I'd like to point out several improvements we plan to implement in order to overcome these challenges. Some of them we've already begun to carry out. First, we'd like to decrease amount of false positive by setting a threshold for n-grams value that will allow us to avoid very low scores that, though may be valid results, too often they turn out to be false positives. Here, the correct positives were marked in blue. The values painted in mauve indicates high n-gram scores. A threshold would give no identification for all low score, eliminating the noise of false positives, next to, unfortunately, some correct ones. Then we'd like to implement a probability score that take into consideration both n-gram score and data from previous line. We believe that the aggregated score might be more accurate than n-gram score or preference toward earlier identifications, each by itself. These 2 measures are entitled to improve result significance. The other components we'd like to upgrade is the index library. First, setting hierarchy between early and late sources is predicted to promote results of works more likely to be an original source rather than secondary text reuse, as Uri explained. Second, allowing a selection of certain sub-libraries in the index shall enable a flexible search tailored to the specific feature of any manuscript and what works best for it. And of course, enriching and enlarging the index library with new sources as well as manuscript versions of existing works is an ongoing goal predicted to strengthen the accuracy of RWFS results. We are looking forward to initiating these upgrades and hopefully make RWFS adaptable to fits for various types of manuscripts and challenges. Thank you.
Many thanks, Vered. Again, please address questions in the chat, and we will answer all questions after Marco Büchler's response. So we were supposed to have now Hadar Miller lecture. Instead, I will provide you with a kind of an overview of our journey to text to use in the current project as well as in other projects. I will, though I cannot present in detail the technical developments Hadar is already implementing, I will point out to some ideas that might solve some of the issues that we have so far with RWFS. Okay, so few comments about text reuse in the study of Rabbinic and other corpora in the Elijah lab. And what I would like to speak of is first to refer to the text, to our turn towards text reuse as an example for DH study and work experience, to tell the story of how we gradually drifted towards this direction, though this drifting is probably a very positive development. I would like to emphasize the tensions which you already sensed in Vered's and Uri lectures, the tensions between sufficient versus robust application, and also the tension between what I would say DH, digital humanities, versus IS, information system validation, which are not exactly the same processes. And then to speak for a little bit about future fantasies. In between, I will present another project of text reuse we've done in the lab, as well as explain the directions Hadar is developing now. So first, as you heard already from Vered and Uri, the journey towards text reuse began in the search to classify Geniza fragments, and it was an outcome of our transcription projects when we realized that we cannot achieve very good or sufficient or excellent transcriptions. We thought, okay, but what we produce still can be helpful for other tasks. For example, for identifying which books are represented in the Geniza fragments, or at least for classifying the genre of the Geniza fragments. And in the hackathon that we had, not in 2021, actually in 2019, in the last 2 years, we didn't have a hackathon in the BSc program in digital humanities in Haifa due to the COVID. And I really hope that we will have new hackathon in the following years, because the hackathon is an amazing opportunity. Many of the projects and the employees and the grants that are around initiated in such hackathons. However, in this evening, in which we realized that Rufus' first design was implemented, and we realized that it can be helpful to a certain extent on Geniza fragments, we also realized that text reuse can be a hammer that we can use on many, many other nails. Mainly the understanding that the efficiency of text reuse in mapping full manuscripts, as you just see, is much stronger than coping with fragments. Also, text reuse efficiency in small tasks related to other projects. We use it for text alignment in Tikkun Sofrim. We intend to use it in other texts. Also, we realized that the process of annotating the text, the raw text, may gain a lot of benefit when we can actually identifying the content of the text and mapping relations and within a presentation that I will not present here, all its elements, but we designed, mainly Uri was working on it, we designed a model for a future library of the Tanhuma literature, in which all the complicated relations between different representations of this literature will be arranged in a RDF and CTS based data model, but the content will also be analyzed and identified. The relations between different units, which you can see here on the screen, will be analyzed by Rufus or other text reuse tools. And lastly, we realized that we can move from rabbinic text to other corpora. And one project that was already done dealt with Arabic medical literature. In a minute, I will speak about this project, but also we aspire and hope to move on to create something which will maybe even enable work with different Arabic dialects. Anyway, I want to tell you a little bit about the Arabic medical literature project, which was a very, very small project. But what is important in this project is actually its dynamics. The project was born out of Rufus. And the model worked like that. We had a very small corpus of Geniza fragments of Arabic medical books, which are unidentified. A simple transcriber, which was a kind of a very simple GUI that DROR ELOVITSA created for us, as a lesson from Tikkun Sofrim, which has a very complicated interface, was used one person only used it, and he transcribed the most rare lines from each fragment. And then they were checked against a reference library, which we actually took from another project in the lab, which is that of the Caliphate, the Jewish communities in the early Islamic Caliphate I mentioned in the opening lecture today. And then, inspired by Rufus, we operated text reuse detection, which led to to successes, namely to unidentified Geniza fragments were identified by that. And what you see here is a very simple, tailored solution with no technological innovation, but it's a product of a lab. It's a product of a group in which different people are working on different tasks, and each one of them can contribute to a very simple building of a modular element that makes that produce efficiency thanks to that. So this is just a comment about the dynamics of digital humanities, and okay. Now, what was presented earlier by Vered and Uri, he also sent us to something which is related to the experience of the humanities scholar when working with those tools, when we are like dancing between the different Rufus output modes. between the line-by-line mapping and the GUI examination with the markering of relevant passages. And therefore, we can define graph-based visualization to examine and to explore hypotheses. And going back from one to another, it ended up with an experience in which we do find interesting phenomena. Now, in this experience, the validation of the algorithm is actually me, namely the person who is an expert in the text, who is saying, yes, thank you. The algorithm turned my attention to an important textual phenomena I wasn't aware of, and maybe better, no one was aware of. And in that sense, for the sake of the humanities, it is sufficient. However, when we want to move on and to use those tools for a robust application that will enable us to provide highly probable identifications of every single line in every Hebrew manuscript out of the 12 million images of pages that soon will be available through KTIV, then we need to work towards something which is more delicate than what Rufus is providing us now. And this will include pre-processing, I will not get into details, rule-based model in which we can define what we should expect from different types of text reuse patterns. For example, when I have two parallel homilies in two different rabbinic works, I should expect that they will have roughly x similar engrams within 100 words. And when I have halachic deliberations, I should expect that they will have y similar engrams in the size of v within 100 words, and so forth. And finding out those relations might enable us to identify different phenomena and to write a kind of rule to search for all those implications. I will move on because I want to spare some time for Marco's response. So one of the tasks that Hadar is already tackling is related to the cases in which Vered presented earlier, in which we have many secondary uses of the text, which provide us actually with false positives. We have the same text quoted in another work, but this is not the text that is really used here. And then the question arises, how can we infer those secondary uses and identify which are primary uses, which are the real sources quoted? And what Hadar noticed is that secondary uses usually have many relations in between them, and they actually create clusters. And within those clusters, only one text is the real text reuse source. And now you have to understand that, and this is how it looks already. There is an improved GUI that following Rufus, but is doing some other elements that Hadar is now developing, but also visualizations of the entire network of relations between the examined candidate, all the results that we have, and the positives as well as negatives. Now you have to understand that for me, as the humanist in the field, in that, I am very happy not only with that, saying that these are positive reuses and these are false. I am very happy with all those relations. I want to go down this graph and to explore and understand why these four texts were found out as related. And if searching for such a fixed statement like Rabbi Yehuda, the son of Simon, said so, okay, and clearly this text is quoted in dozens of places and it will give us so many wrong hits, But look at that. The interrelation between the wrong hits is telling me a story that I have to explore. What is this story? There is a cluster, there is a kind of clustering of sources that has this quotation in them, and you see what we create. This is the back and forth dynamic I was speaking of earlier today. The dynamics in which I'm asking one question, but the outcome might turn my attention towards other, maybe not less important insights that the text is sharing with us. Okay, so where do we hope to go on from here? We hope to go towards robust cataloging of mal-transcribed Hebrew manuscript, a dynamic library of Tanhuma literature based on the identification of relations, and also applying text reuse for improving HTR models, as text reuse is providing us with a way to find feedback and to retrain the models. And finally, maybe developing a triple app virtual research environment for text reuse. The three elements of this triple app will be the GUI interface, full manuscript line-by-line mapping, visualization. Just imagine that now everything we are doing is based on, still on actually work that Uri is doing. But imagine that all of this will be structured within one framework, as in eTracer, where you have helpful frameworks. We will hear. That's the future. This is where we are approaching. I know that I could not represent not the technical details of what Hadar is doing now, but I hope that this improvised presentation gave you some ideas about where we are heading. And with that, I can move on to Marco Büchler. Clearly, one of the leading figures in the field of text reuse applications for digital humanities. Marco is maybe I would say the founder, if not the spirit behind eTracer and eTrap and other services which are already available in the web for text reuse. And I think there's no one in the world which is suitable to give a response to our very initial efforts in the field of text reuse as Marco. Please.
Thank you, Moshe. These were extremely kind words. I feel very, very honored to give you here my response. If you look in digital humanities and the field of text analysis to different tasks, you have tasks like stylometry, where you take a text, plug them in a tool, and 30 minutes later, maximum, you have something out. All of this is text reuse for sure not about. All of you who, like Sinai, who ever worked on text reuse know that modeling text reuse is very, very, very challenging. And I think this is what we all have seen from the 3 talks here today, that it's a lot about which parameters fits in which scenario best, and not the same setting that work here better do not necessarily have to be the right and the best for in another scenario. And I think this came very clearly out. I have some very general remarks and some talk-specific remarks that I would now give feedback for. I think what the general remark became very, very clear is that there's a need for identifying small text reuse. Identifying bigger chunks of reuse is rather simple, but making a distinction, and this all became very clear from Vered's talk, for smaller chunks is very, very challenging. Just to give you a number, in our experience in my lab, we figured out that, especially in antiquity, about 80% of the text reuse, focusing on Greek and Latin, have a size of 2, 3, or 4 words. And if you look at 2, 3, 4 words, and you have something like to be or not to be, a sequence of function words, while on the other hand, you have something like golden calf that alludes to the Bible, Yeah, why is both working? Yeah, this makes identification of small chunks of reuse extremely challenging. So why is golden calf and I have here blue sky? Why is blue sky not alluding to nothing, but golden calf alludes to a Bible? So linguistically, they are the same, but from a textualist point of view, they have completely different effects on identifying an illusion versus being a false positive. One thing I can say is, for the first talk of Uri, if there's an interest in some speed improvements, we made some recent analyses for how to speed this process up. This is literally finished a month ago. I don't want to stretch this here too much in detail because this is extremely technical in the background, and it's about bitmaps and things that might be in a humanities context not the right place to be. But at least I would like to have this announced here. Something that I also noted down is, please do make all the false positives you found available. Yeah, not just focus on the positives you are interested in, the true positives, but also please make the false positives available to the researchers. And as soon as you have data collections, both with the positive findings and the negative findings you are not interested in, and you try to identify what is the difference, why do you like the one and the other ones not, you will figure out that modeling textures becomes a completely new challenge. Yeah, as with simple metrics like counting words or n-grams, you will see that this will be not the immediate response. So also for the community, please make the false positives available. And if there's a possibility, also explain briefly why it's for you in false positive. I'm also, and I'm now jumping between my notes from the 3 talks, along to this line, also consider inter-rater scores. So when we matched in our lab critical additions, or text uses from critical additions to our outputs, we saw that our experts disagreed with what was written in the critical addition, not by the passage found, but by the interpretation. Is it a paraphrase? It is a quotation, or what is it? And so I think we should not consider a finding as something absolute, but we should consider seriously that this kind of using the crowd, using the wisdom of the crowd, will give us additional benefit on sharpening our idea on why something quoted and what is considered to be relevant and what not. A general remark over all presentation is, as you're working on Hebrew here, please try to consider text use on roots of words. Yeah, so in Germany, I'm very jealous on this ability because we don't have it. But I think also going way, way beyond literal translation or verbatim translation or text use, this will really, really be of benefit, I think, to identify further reuses and maybe also to remove some false positives you are not interested in. In Uri's talk, but this is maybe something that I missed. It was not clear to me how the scoring came together. There were comparably low scores of 18 or 9%. I think it's something like an overlap or similarity, but I at least could not judge from scratch what this could mean. Also regarding Uri's talk, I think it was more in the outline, you also spoke about further improvements for using synonyms. I just encourage you to look also for further semantic explanations. We figured out that the usage of synonyms is at the same level as those of the co-hyponyms. Co-hyponyms are, for example, cat and dog. They are the animals that you are at home to say that have the same hyponym. And this simply comes with the fact that if you look at historical data, it's very difficult to find two concepts that are stable in the semantic relation to each other over a long, long time. So co-hyponyms in historical texts, something, let's say, similar, even if the meanings of the words might change over the centuries, is, from my experience, often better than just looking on synonyms. This may be for Uri's talk. On the second talk, I got this trigger I had a few years ago. It's a positive one that I think we need for text reuse, and this I just got a kind of a déjà vu analysis on how good can our text reuse algorithms really perform on different degrees of noise. With noise, I mean here character error rates. Yeah, so if you have different types of character annotated text, you have low character errors, higher character error rates, and at which scale text reuse algorithms can still perform, and then they simply suck and don't do anything anymore. I think this would be good to see, also get an understanding of where, for Hebrew, there's this kind of a threshold where you can still accept the output and where it's simply too noisy and text reuse can't help you with anything anymore. As there were no slide numbers, it was very difficult to now align to the right context, but this manuscript Palmer 3122, I'm very, very much in favor with this example. Or when I got the slides in advance, I was really in love with this part, and I just can encourage you, please publish, please publish, please publish. The distinguishing, this was in the end of the talk, of small text reuses. That's a true challenge. This is how I introduced the section, my response. And I think there's no universal answer on this question right now. The smaller the reuse, the more difficult it is to identify what is noise and what is something positive you want to have. Regarding the probability score, we made experiments on this. I was not that satisfied from this. This is simply by the fact that with words you have a power law distribution, and we published then caused by the Zipf's law. This means that 50%, round about 50% of the words in a corpus, independent from size, occur only once, about 16% occur twice, about 8% occur 3 times. And you sum all of this up, we define in our lab the 90-10 rule. This means that more than 90% of the words occur 10 times and less. And with other words, you have, for the majority of the words, you have so little probability that if you begin to work with probabilities, everything will be a statistical surprise if you just consider 2 or 3 words. So this was in the end our result, and this may be...
Which is actually taken on board by Hadar, actually. Okay.
And regarding the third talk, I made noted 3 things. 2 already I mentioned. Please annotate also in your RDF graph the false positives. You can always ignore them when you want to display results, but in the beginning you had this
unmute yourself. Somehow you were muted.
I don't know why I was now muted. Probably I talked too long. So in the on slide 4 of your presentation, on what was this title, linking paragraphs RDF, I just can encourage you also to consider to annotate the false positives and to really track them through the application. For proper application, you can always ignore them, but I think the false positives are for research purposes the best part to have. I also mentioned the iterator scores and the text reuse inference. I just noted down, I'm in love with this. I really fancy this idea, and this is what I can say. Let me check if I, yeah. I have one little last note. I put this on the back on one of the sheets, just to be aware of that. I want to say this as a last thing. I think it's always important also to make expectation management. When you compare textures with critical editions, we figured out, we started with 1.7 million euro in 2015. And we, in several experiments, we experienced every time the same, maybe Latin, maybe Greek, maybe Coptic, that the new findings were extremely little. These new findings, I really mean here findings that were not on the critical editions or on these indexes of text reuse of the well-studied authors. It was always something like less than 10. Often with, what was the Latin author? I can't remember. Greta Francini made this work, it were 2 or 3. Yeah, but the 2 or 3, this were then really important. So with all this quantitative methods, it looks like a bit disappointing to in the end find very little really new findings that are relevant and no false positives. But the more important, this very few findings are. And I guess with Hebrew, it might be the same effects here. That's me.
Thank you very much. I guess it will be difficult to address so many notes, and we will also be very recorded, and we will take them on board. Are there any further questions from the crowd, or Uri or HTRed want to respond to one of Marco's many comments?
Just one regarding this. Just one regarding the. Can you hear me?
Mm-hmm.
Yes.
Regarding the scores, they're all relative. So what you see, the score is actually just the ratio between the number of n-grams found to match the document and the number of n-grams in the input text, and they're simply sorted so that the best one is the document that resulted in the highest number of n-grams that matched it. So it's really a simple scoring for now. We're not looking into the quality of the result.
If you want, I can send you some alternative models. And this is a standard problem. As the size is one thing, but if you have a long document with maybe 19 n-grams shared, but let's say 5,000 or so n-grams, then you have an extremely low score. Yeah, but nevertheless, this ratio would be, this texture would be super significant. I think it's difficult without a whiteboard here to explain, but if you want, I can send you some other metrics that are also super simple to implement, but might be here or of help to consider both the overlap, but also the size of the overlap at the same time.
Right. And how they cluster, I mean, the geographical arrangement of these n-grams.
Mm.
Great, that will be great. Thank you.
Any further questions? So I shall thank, there's one question in the chat, but we are 1 minute toward the end. So we shall conclude the session now, and people, as we done in formal breaks, people may chat during the break. The Zoom is still open, and we will, many thanks to Vered, to Marco, to Uri, and we will gather here again at 7:30 for the next session, which is analysis of metadata responsa, methods and findings. So see you soon.